Question 3 asks us to simplify some monomial expressions. And again, when we say simplify, we want to reduce the number of operations needed to evaluate these. And another consideration is we don't want to leave expressions with negative exponents in them anywhere. So A is pretty straightforward. If you look at it, there are exactly 1, 2, and then 3, 4, 5 factors of x. And in terms of y, there's 3 factors of y here and then 6 additional factors of y. So the simplified form for this is there's the number 7. So it is 7 and then times x to the 5th power and then times y to the 9th power. That's it for that. Let's go on to B. Probably the thing that I like to take care of first is, well, it depends. Sometimes I'll take care of it first, sometimes I'll simplify some parenthesis things before, but I want to deal with this negative exponent. So this expression right here, right, I realize I'm going to multiply by the rest of it at the ends, but let's just look at this in kind of an isolation. So I've got 3x to the negative 2nd power. So 3x raised to the negative 2nd power. And our primary vehicle for dealing with these is using multiplication by the number 1. So if I want, I could multiply this by something that would neutralize the negative exponent. So for example, if I have the same base 3x and I multiply it to the positive 2nd power, if I simplify that numerator, it's going to be 3x to the 0 power, which equals the number just 1. We know that. Now, we can't just multiply by 3x squared, right, because it would change the value of this expression. So we need to multiply by the number 1. So I'm going to look at 3x squared over 3x squared. So if I'm taking a look at this, now I can see that this is in my top, in the numerator, there's 3x again to the 0 power, which equals just 1. And in the denominator, we've got 3x squared. And if I consider the 3x squared, that's 3x times 3x. So I could write that as 9x squared. So this, right, it's a lot of writing here, but I just want to be really clear, right? There's no guessing what this is. This is exactly 1 over 9x to the 2nd power. So because that's what that is, I can rewrite this entire problem as 27 x to the 4th, y to the 2nd power, and all of this is divided by 9x to the 2nd power. So certainly some more to be done there. If I'm looking at 27 over 9, that has a giant 1 of 9 over 9, right? 27 divided by 9 is 3. X to the 4th power over x to the 2nd power is just x to the 2nd power. And then there's that y to the 2nd power in the numerator still. So the answer is 3x squared y squared. So let's turn our attention to finally part C. And part C has it does have a negative exponent in it, and I think I want to take care of that first. So I'm going to choose to multiply this by 1 over y to the 2nd. I can't do that. I have to multiply it by y to the 2nd over y to the 2nd, or I'll change the value of it. So again, the idea here is it's okay to multiply by the number 1. You don't change the value of your monomial. And if you look at it, now I've got y to the negative 2nd times y to the 2nd, which is y to the 0 power, which equals 1. So just simplifying that part of it, right, we've now got 3x squared all over 6x and then y to the 5th power. So I guess there's a couple more things we can do, right? 3 over 6 is the number 1/2. So I can write this as 1 over, and there's a 2. And in my denominator, I've got a single factor of x. So x squared divided by x would give me this factor of x in the numerator. And then I've got a y to the 5th that's still in the denominator. So I don't need that 1 there explicitly at the end. So I'm just going to write my answer as x divided by 2y to the 5th power.